Hi everyone, good day. Welcome back to our next video. In this video, we will discuss about two-dimensional arrays in C. Let's move on to the video. If we want to store a single value, we use the variable. If we want to store a row of elements, then we use the single dimensional array. Suppose if you have a data in the form of a table, that is in rows and columns, how do you store such data? So this can be done in C by using a two-dimensional array. We can use a two-dimensional array to store data which is in the form of rows and columns. A two-dimensional array has its elements arranged in a rectangular grid of rows and columns. A two-dimensional array is an array of one-dimensional arrays. It can be visualized as a plane that has rows and columns. Each row is a single-dimensional array. The elements of a two-dimensional array can be accessed by using a row subscript and column subscript. A two-dimensional array is popularly known as matrix. An array that contains two subscripts is called a two-dimensional array. The syntax for declaring a two-dimensional array, we have to specify the data type. So in two-dimensional array also, all the elements belongs to the same type only. So specify the data type of the array followed by the array name. Then we have to specify the row size and column size. So as we know, in two-dimensional array, the elements are stored in the form of a table in rows and columns. We need to specify two subscripts, row size and as well as the column size. Say for example, int a of 3, 3. So here the data type is integer. The name of the array is A and the number of rows is 3 and the number of columns is 3. So here totally the two-dimensional array can hold 9 elements. So as we know that it is a form of matrix, here 3 cross 3, 9 elements can be stored in this two-dimensional array. So see this picture representation. So how we can access the element? By using the two subscript operators, row operator as well as the column. So in the row size, it indicates us how many rows are there in the two-dimensional array. The column indicates how many columns are there in the two-dimensional array. So when I say A of 0, 0, it means that in the array A, we are going to store the element in the location 0, 0, the 0th row and 0th column. So if I say A of 2, 2, it means that I am going to store the element or read the element from the location in the second row, second column. So the specification of row size and column size is mandatory if an initialization list is not present. If you do not initialize values, it is mandatory to give both the row size as well as the column size. If initialization list is present, the row size can be skipped, but it is mandatory to mention the column size. Initialization of two-dimensional array is similar to single-dimensional arrays. So here we have to give the initialization list. Say for example, int a of 3, 3 is equal to, within curly brackets, we can give the list of values. So since we have to give 9 values, we will give us 1, 2, 3, 4, 5, 6, 7, 8 and 9. So how to represent this in the form of rows and columns? So we have 3 rows here. As the array subscript starts from 0, we will start from row 0, 1, 2. So column is also named in the same way. Column 0, 1, 2. So the data elements are entered row first order. So first 1, 2 and 3 will be entered in the first row. Then 4, 5 and 6 will be entered in the second row. Then 7, 8 and 9 will be entered in the third row. So it initializes the element of the first row as 1, 2 and 3. Second row as 4, 5 and 6. And third row as 7, 8 and 9. The initialization here is done row by row. First be enclosed within a curly bracket. So this way also we can initialize. If the values in the inner braces for each row is less than the size, then the remaining values will be set to 0. So as how we are doing it in the single dimensional array, if we do not have sufficient values, then the remaining locations will be automatically set to 0. Say for example, int a of 3 is equal to curly bracket. So first row we are enclosing it inside another curly bracket, giving only two values 1, 2. For second row only one value 4, and for the third row 3 values 7, 8 and 9. You can see here for the first row we have not specified one value, and for the second row we have not specified two values. So that will be automatically set to 0. So in representing this in a table form, a of 3, 0th row, first row, second row, 0th column, first and second columns. So enter the data for the first row 1, 2, third element is 0. For the second row, we have only one element 4. The remaining two elements are set to 0. The third row, we have all the three elements 7, 8 and 9. Suppose if it is a float type, it will be automatically set to 0.0. If it is a character data type, it will be set to null character. When the array is completely initialized with all values explicitly, then it is not mandatory to specify the row size. Say for example, int a of, you need not specify the row size, you just specify the column size. So column size is mandatory, 3 equal to curly bracket. So first row again I am enclosing it within another curly bracket, 1, 2, 3. The second row 4, 5, 6. Third row 7, 8, 9. So here we have initialized all the values for each row. So in that case, it is not mandatory to specify the row size, but column size is mandatory. The elements of a two-dimensional array can be accessed by using row and column subscripts. Say for example, a of 0, 0. Here first 0 is 0 subscript and the second 0 is the column subscript. So we can, when we declare a two-dimensional array, we can go up to n-1, which is the size of the row as well as the size of the column. This program explains the usage of a subscript operator. Here we are declaring a two-dimensional array of row size 2 and column size 2, and we have initialized the values 1, 2, 3 and 4. So we will represent this in the form of a table. So we have 2 rows and 2 columns. As the array subscript starts from 0, row 1, column 0, column 1. The values are entered as row first 1, 2, 3 and 4. So you see in the printf statements, we are accessing the element by using the subscript operators. A of 0, 0, which means that it represents to the first 0th row, 0th column. The value will be 1. So it will print the value 1. Similarly, the next element refers to the 0th row, first column. The value, equivalent value is 2. The second printf, we are accessing the row 1. So row 1, column 0, the element is 3. Row 1, column 1, the element is 4. So here we have initialized only 4 values. It is a small two-dimensional array. So we are not using any loops here. But when we want to read more elements, then we have to go for the iteration statements. So single dimensional arrays can be used by using a single iteration statement. When we go for two-dimensional arrays, we need to use nested loops. So nested for loops can be used to read and store two-dimensional array. This program is an example for reading and printing elements inside a two-dimensional array. Initially, we have declared a two-dimensional array A. The row size is 10 and column size is 10, which means in this two-dimensional array, we can read maximum of 100 elements. So we can also customize the row size as well as the column size. So we have used another variable rs and cs to read the row size and column size at runtime from the user. We are initialized two loop control variables I and j. As we are going to use nested loops for reading and printing elements in a two-dimensional array, we are using two loop control variables I and j. The first is scanf statement. We are reading the row size and the column size. So here we will consider it as a very small number so that we can understand it clearly. We will run the program. We will enter the row size and column size. We will take it as 2 and 2. So it will ask for the elements. So the elements are entered by using the nested for loop. You can see here, enter the elements of two-dimensional array. We have used two for loops. I is equal to 0, I less than, row size I plus plus. So within that for loop, we have another for loop for j is equal to 0, j less than cs, that is a column size j plus plus. So the first outer loop indicates the row and the inner loop indicates the column. So for each row, the inner loop will be iterated completely, which means that when you take row 0, you will read all the elements in the column. Then again for row 1, we will read all the elements in the column and it will go so on. So here we are entering the elements now. We will take it as 1, 2, 3 and 4. So the elements are printed. It will be displayed as 1, 2, 3 and 4. For displaying also we are using the same concept. We are using the nested for loop. So here when we are reading the elements, how it is stored? In A of 0, 0 it will store 1. In A of 0, 1 it will store 2. In A of 1, 0 it will store 3. And in A of 1, 1 it will store 4. Although two-dimensional array is visualized as a plane which has rows and columns, they are actually stored in a linear sequence in the memory. That is, the multidimensional array is converted to a one-dimensional array and stored in the memory. We can do this by two ways. Either use the row major order of storage or column major order of storage. In C language, multidimensional arrays are stored in the memory by using the row major order of storage, which means the elements of an array are stored row-wise in contiguous memory location. Say for example, here we have declared and initialized a two-dimensional array int a of 2, 2 which is equal to 1, 2, 3 and 4. We have initialized the values. So this is the table form of the declared two-dimensional array. So here we have elements stored in rows and columns. So how does this element get stored in the memory? So they are converted into a linear sequence, which means that the first row elements 1 and 2 will get stored first, followed by the next row elements 3 and 4 and so on. So how many ever rows we have, the elements are stored in the memory linearly row-wise. So this is how two-dimensional arrays are stored in the memory. The main advantage of using array is that direct indexing. By using the subscript operators, we can directly access the element in any location. How much ever the array, the size of the array might be, the time required to access any element in an array is the same irrespective of the location in the array. The disadvantage of using arrays is that it's static memory. The size of the array cannot be changed at runtime. The memory is allocated at the compile time itself, so we cannot change it during the runtime. So we say we are having a static memory in the array. So the size of the array has to be always kept big enough to accommodate the worst cases of elements. Therefore, memory usage in case of array is very inefficient. In this video, we discussed about the two-dimensional arrays. In the next video, we will discuss about strings and C. Hope this video was useful to you. If you find it useful, kindly like, share and subscribe the video. We will meet in the next video. Thank you.